Hello, in this lesson, can we talk about the factorial concept? So, the factorial concept, if I represent it like with n factorial, what I mean is how many ways n distinct items can be arranged or ordered. So, let me give you an example. If I have a red shirt, a blue one, and a green one, somebody is asking me, how many ways can I arrange these three unique shirts? Unique in the aspect that I'm using the color as identity. So in this case, if I say I have the red, blue, and green like that, then the first arrangement, I already have the red. I can say I have the red, but I'm remaining with the blue and then green one. So I can put the blue there and then green. And that's the first arrangement. But then again, in the second one, I already have the blue one. So the remaining ones are just the red and then green one. So I can put them here, red and green. Then in the third one, I already have them green. So the remaining ones are the red and blue. So I can put them here. Then, if you check well, again this one, I can arrange it like this. Then arrange it as red, green, blue. And just interchange this green now can inside. And then this one, I can arrange it as blue, green, blue, green, red, like that. And then this one, I can arrange it as green, blue, then red, like that. So the number of arrangements here would be 1, 2, 3, 4, 5, 6. So instead of doing all this work, why not then just take the number of shirts I have, which are 1, 2, 3. And then I say our n here now, n is equals to 3, but now factorial, which means when I put this factorial, it means I take that 3 and I multiply by all numbers less than 3, but not 0. So in this case, I multiply by 2 and then I multiply by 1, but I don't go beyond 1. The last number must be 1. So it becomes 3 by 2 by 1, which is 6 arrangements, the same way we got it here. So in short, if somebody tells you, gives you a number and tells you to find its factorial, for example, somebody gives you 4 factorial, what it's telling you is just take 4, multiply by the numbers less than 4, but still the last number must be 0. So it will be 4 by 3 by 2 by 1. The last number must be 1, not 0. So it will be 4 by 3, which is 12. 12 by 2 is 24. By 1 is 24. So that's what factorial means. So if I can show you again here, as the table for factorial, or as the n increases, the multiplication of the table for factorial also expands. You see, when I add 1, we just add one number. When I have 2, now it becomes 2 by 1, which is 2. Then if I have 3, it becomes 3 by 2 by 1, which is 6. So you see, as we go down, replacing the number of the n value with them being a number, then factorial also increases to a higher number, and also the expression becomes big. Why? Because the numbers you are multiplying with now also keep increasing. Then if we go maybe to 4, you see now it becomes 4 by 3 by 2, which is 24. So the most important thing to note is that in factorial, first, we need to know that the last number must be 1, the last number you're multiplying with, and then the first number must be the n you are given. For example, if you are given 4, 4 must be the first number, then the last number must be 1, then the numbers which are in between are whole numbers less than the number you are given. Like in our case, it was 4. So all the numbers less than 4 are 3 and 2, and then the last number must be 1. Same for 5 and any other number you'll be given. 5 by 4 by 3 by 2 by 1. So can we try an example here, which is 6 factorial divided by 3 factorial, then 2 factorial. This is just simply meaning 6 by 5 by 4 by 3 by 2 by 1 divided by 3 factorial is the same as 3 by 2 by 1, then again multiplied by 2 factorial, which is the same as 2 by 1. So if I have to cancel this one, I can cancel this 3 with this one, can cancel this 2 with this one, I can cancel this 2 by 2 by 2, and what remains is 6 by 5, which is 30 by 2, which is 60. So the answer becomes 60. But I want to show you another simple way to do this. Let me show you, but now with another example. If I give you 8 factorial divided by 5 factorial and then 3 factorial, what I mean is, why don't I take 8 by 7, then by 6, right? Because we are starting with the highest, which is 8, 7, 6. But then again, because here I have a 5, I can just put a 5 factorial like this. Then I divide by 5 factorial multiplied by 3 factorial. But I want you to note this. Here above, when I put 5 factorial, what I mean is again 5 by 4 by 3 by 2 by 1. Anyway, what we would have put here, if we continued, I would have put by 4 by 3 by 2 by 1. So instead of going now that, because I have a 5 factorial here, why don't I just cancel that one with that one? Then I remain with 3 factorial. So I can take now 8 by 7 by 6, and then by 3 factorial, which of course means 3 by 2 by 1, and then it becomes 8 by 7 by 6 all over 3 by 2 is 6 by 1 is 6. So this 6 goes with this one, and then I remain with 8 by 7, which is 56. I think 56. Yes. So can we try another example? Let me see if you have another good example. Yes, let's try this one. If I say 10 factorial divided by 10 minus 4 factorial, then 4 factorial, what I simply mean is, let me stick with that 10 factorial for a start. Then I take 10 minus 4 is 6, and now 6 factorial. I've just opened the brackets, then again 4 factorial. So look at this. If I take 10 factorial, it's the same as just saying 10 by 9 by 8 by 7, and now by 6 factorial, because even if I continue reducing by 5 by 4 by 3 by 2, it's kind of like I've just written 6 factorial is 6 by 5 by 4 by 3 by 2 by 1. So instead of continuing with all this, and I still have 6 factorial here, why don't I just leave it at this point? Then I divide by 6 factorial, then 4 factorial. But you see, this one will go this. Then I remain with 4 factorial. I can now say 10 by 9 by 8 by 7. Then all over. This 4 factorial is the same as 4 by 3, right? By 2 by 1. Then it becomes, why don't I do this one by that one by 4 is 2, then by 3 is 1, by 3 is 3, and then I divide this by 2 is 1, by 2 is 5. So 5 by 3, which is 15, 15 by 2, which is 30, 30 by 7, I think it's 210. And then I'll get, there you have your answer. Before we finish off this lesson, I want to show you a very special case. Do you know, though we have said if we get n factorial, it means we pick all the numbers which we have been given the value for n and then multiply by all numbers below it, but the last number must be 1. So for example, if I have 3 factorial, I will take 3 by 2 by 1, which is 3 by 2 by 1, which is 6. But do you know 0 factorial is 1? Yet we don't even have any number to multiply by 1 here. Like we can't multiply any value with 1, 0 is the last one. So actually, to prove to you this, can I try it in my calculator? 0, then factorial, you see it's 1. So how is this possible? Logically, if you check well, we said factorial tells us how many ways unique items can be arranged. So, if that is the case, for example, let's say you have, for example, 3 shirts, the way we had. Then we arranged them in 6 different ways, which is okay. Then, how about if we had 2 shirts? Those 2 shirts, we could arrange them in 2 ways, which is 2 factorial, of course. 2 by 1, which will be 2. So we can arrange them as blue, and we can also arrange them as blue-red. And then, if we have only 1 shirt, for example, a red shirt, we can only arrange it in just 1 way, which is 1 factorial, meaning that 1 shirt, of course, you don't have another to combine with. Then it means 1 factorial will be 1. You can just arrange it in 1 way. But then, if you have 0 shirts, you can only arrange them by doing nothing. Because in the first place, you don't have anything to arrange. And then, doing nothing actually in mathematics is counted as an event. And that's why, if I ask you how many ways can you arrange in 0 shirts, you'll tell me I can arrange them in a 0 number of ways. That means in that 0 number of ways, then you already have a 1 way to arrange, which is actually doing nothing. And that's why 0 factorial is 1 and it is not 0. Thank you for now. Let's meet in the next lesson.